Imagine walking into a convenience store at 3 in the morning and finding a meal so perfectly crafted that professional chefs stop to take notes. Picture unwrapping an onigiri and discovering an engineering solution so clever it keeps the seaweed crispy until the exact moment you're ready to eat. Think about a food distribution system so precise that a store in rural Hokkaido receives fresh sushi at the same quality level as downtown Tokyo. Japan didn't just build convenience stores. They built a parallel food infrastructure so sophisticated that food critics had to create entirely new categories to evaluate it properly. And when Michelin inspectors finally started paying attention, they realized something the rest of the world had been missing. Some of the best food experiences in Japan weren't happening in restaurants at all. We're counting down 15 innovations that transformed Japanese convenience stores from quick shopping stops into something the global food world had to start taking seriously. Number 15. The three-layer thermal container engineering that keeps hot food hot and cold food cold in the same bag without any electrical components. You finish paying at a Family Mart and the clerk starts a sorting process that looks almost ritualistic. Hot items go into one specially designed bag. The material isn't just insulated, it's structured with air pockets positioned at mathematically calculated intervals. Cold items go into a different bag with a completely different thermal architecture. But here's where it gets interesting. If you're buying both hot and cold items, they use a third bag type with an internal separator. This separator isn't just a piece of cardboard. It's a multi-layer barrier made from materials that reflect heat on one side and absorb ambient temperature fluctuations on the other. The thickness varies depending on seasonal temperatures. Summer versions are slightly different from winter versions. Your hot katsu sandwich stays at proper serving temperature while your ice cream remains frozen solid, sitting in the same bag for up to 40 minutes. Meanwhile, everywhere else, we're just hopping our ice cream makes it home before turning into soup and accepting that our hot food will be lukewarm at best. Japan looked at the fundamental physics problem of temperature maintenance and solved it with material science most restaurants don't even use. Number 14. The rice texture preservation system that keeps convenience store onigiri at ideal moisture levels for 72 hours without refrigeration hardening. Every country that has tried to sell pre-made rice products in convenience stores hits the same wall. Cold storage turns rice into a dense, unpleasant brick. But in any Lawson or 7-Eleven across Japan, you can buy an onigiri that tastes like it was formed 20 minutes ago, even if it's been sitting on the shelf for 2 days. The solution is a three-part process most customers never notice. First, the rice is cooked with a specific water ratio that's slightly higher than normal, compensating for moisture loss during storage. Second, it's treated with a nearly invisible coating of sake-derived enzymes that slow starch retrogradation, the chemical process that makes rice go hard. Third, and this is the critical part, the packaging itself is designed with microscopic perforations that allow just enough air exchange to prevent condensation while maintaining humidity at exactly the level rice needs. The perforations are laser cut at different densities depending on the filling. Tuna mayo onigiri have a different perforation pattern than salmon because the moisture content of the filling changes how the rice behaves. You peel open that package, and the rice has the exact springy texture of freshly made onigiri because someone engineered a storage environment that maintains it at the molecular level. This isn't just good for convenience store food. This is food science that most professional kitchens would struggle to replicate. Number 13. The noodle reheating protocol that convenience store staff follow to prevent sogginess using a hot water bath system with timing mechanisms built into the packaging. You grab a cup of ramen or udon at a 7-Eleven and at the register the clerk doesn't just hand it back to you. They ask if you want hot water. You say yes, and what happens next is more precise than most restaurant kitchens. The cup has 2 indicator lines. The clerk pours hot water to the first line, then sets a timer. Not a guess, an actual timer. For ramen, it's exactly 2.5 minutes. For udon, it's 3 minutes and 15 seconds. For soba, it's 2 minutes flat. These times aren't arbitrary. They're calculated based on the starch content of each noodle type and the temperature the water will be after the walk from the store's hot water dispenser to the counter. The second line is for the soup base, which goes in after the timer. Why? Because adding it too early causes the noodles to absorb too much sodium and become mushy. Adding it at the exact right moment means the noodles finish hydrating just as the soup reaches ideal serving temperature. You walk away with a cup of noodles that has the correct texture, correct temperature, and correct broth concentration without you having to think about any of it. Everywhere else, we just add boiling water and hope. Japan turned it into a calibrated process with engineered timing. Number 12. The fresh food replacement cycle system that uses predictive logistics software to swap inventory 4 times per day based on neighborhood foot traffic patterns. This is where convenience stores in Japan stop being retail locations and start being logistics showcases. Every Family Mart and 7-Eleven in the country is connected to a central tracking system that monitors sales velocity down to the individual product. But it doesn't just track what's sold. It tracks what sold when to whom and under what conditions. Was it raining? Was there a local event? Did a nearby office building just let out? The system compiles this data and builds predictive models for every single store. Then it schedules deliveries, not daily deliveries, 4 deliveries per day. The morning truck arrives between 5 and 7 with breakfast items optimized for commuters. The midday truck comes between 11 and 1 with lunch inventory. The evening truck arrives between 4 and 6 with dinner and afterwork snack items. The late night truck comes between 10 and midnight with items that data shows sell to late shift workers and students. Each truck doesn't just restock, it swaps out items that the predictive model says won't sell in the next cycle. If you walk into a convenience store at 8 p.m. and see fresh sandwiches on the shelf, they weren't sitting there since morning. They arrived 4 hours ago because the system knew evening customers buy different sandwiches than lunch customers. The result? Almost zero food waste and the freshest possible product at every hour. Meanwhile, most convenience stores in other countries restock once a day and just accept that things will be stale by evening. Japan built a distribution network that treats every 6-hour block as a completely different inventory challenge. If you're starting to realize that Japanese convenience stores are operating on a completely different level, go ahead and subscribe, because what's coming next gets even more specific. These aren't just smart retail decisions, they're entire systems that other countries haven't even considered building yet. Hit subscribe so you don't miss the rest. Number 11. The seaweed separation film technology in onigiri packaging that keeps nari crispy in a humid environment until the exact second you pull the tab. This is the innovation that makes food engineers actually stop and stare. Nari, the seaweed wrapper around onigiri, goes soggy within minutes when it touches rice. That's just physics. Moisture migrates. But when you buy an onigiri at any Japanese convenience store, the nari is crispy enough to crackle when you bite it, even though it's been packaged with moist rice for potentially days. The solution is a 3-layer pull-tab wrapper that seems simple until you understand what it's actually doing. The rice is wrapped in a thin plastic film. The nari is held in a separate outer layer. Between them is a middle layer that creates a moisture barrier. Here's the brilliant part: when you pull the tab, you're not just opening the package. You're following a precise sequence engineered into the wrapper itself. The tab splits the outer layer, which releases the nari. Then it peels away the middle barrier layer while simultaneously removing the inner plastic from the rice, all in one pull. The nari and rice make contact for the first time in your hands, seconds before you eat it. The engineering required to make this work is absurd. The plastics have to be strong enough to maintain separation but weak enough to tear cleanly in the right direction. The adhesive that holds the layers together has to release at different rates depending on pull angle. This isn't packaging. It's a precisely choreographed material sequence that happens in 2 seconds, and it exists just to keep seaweed crispy. Japan didn't need to solve this problem. They could have just accepted soggy nari like everyone else. Instead, they engineered a solution so elegant that it's taught in packaging design courses. Number 10. The sandwich cutting technique that Japanese convenience store suppliers use to create structurally stable cross-sections without compression damage to soft fillings. You pick up a sandwich at a Lawson, it's cut into perfect rectangles, the edges are clean. The filling, even if it's egg salad or tuna mayo, hasn't squished out the sides. The layers are visible in cross-section like a geology diagram. This seems normal until you try to replicate it. Cutting a soft sandwich so the edges stay clean is nearly impossible with standard kitchen techniques. Press too hard and the filling compresses and oozes. Press too light and the bread tears. Japanese suppliers use ultrasonic cutting blades. These blades vibrate at frequencies high enough that they're not actually cutting the sandwich through pressure. They're using vibration to break molecular bonds in the bread and filling. The result is a cut edge so clean it looks laser-made, but the technique goes further. Before cutting, the sandwiches are chilled to a specific temperature, different for each filling type, that makes the ingredients firm enough to cut cleanly without becoming so cold that they lose texture. Egg sandwiches are cut at 4 degrees Celsius. Katsu sandwiches are cut at 7 degrees. The difference matters, and the blade angle is adjusted based on bread thickness. Thicker milk bread requires a 15-degree angle. Thinner sliced bread uses 20 degrees. You end up with a sandwich that looks professionally assembled because it was cut with precision equipment calibrated to the specific structural properties of its ingredients. Meanwhile, most pre-made sandwiches everywhere else look like they were cut with a butter knife by someone in a hurry. Japan industrialized sandwich cutting and turned it into an engineering discipline. Number 9. The layered salad packaging system that keeps ingredients separated by density until the moment of mixing using gravity-based design instead of dividers. You buy a salad cup from a Family Mart. It looks like a normal plastic container. But when you open it, you realize the ingredients aren't mixed. The dressing is at the bottom, then a layer of hearty vegetables like cucumbers and tomatoes, then softer items like lettuce. At the very top, crunchy toppings like croutons or nuts. The container has no dividers, no separate compartments, it's just one cylinder, so how does everything stay separated for days? The answer is specific gravity and material science. The dressing is designed to have a higher density than any of the vegetables, so it naturally sinks and stays at the bottom. The vegetables are layered by moisture content and weight. Heavier, water-dense items like tomatoes go in first. Lighter, air-filled items like lettuce go on top. But the real innovation is the film barrier that sits between layers. It's not a solid divider. It's a nearly invisible edible film made from vegetable starch. It's strong enough to prevent ingredients from mixing during transport but dissolves within seconds when you shake the container. You snap the lid back on after adding the dressing, give it a few shakes, and the film dissolves completely, leaving no trace, no plastic to remove, no weird texture. The salad mixes itself through the shaking motion and the film just vanishes into the dressing. This is packaging that actively participates in food preparation. And it only works because someone calculated the exact dissolve rate of vegetable starch film in different dressing pH levels. Japan turned a salad container into a release preparation system. Number 8. The hot food case technology that maintains different temperature zones within a single display unit, letting fried chicken sit next to steamed buns without either one degrading. Walk up to the hot food counter at any 7-Eleven and you'll see fried karaj, steamed nikumen, grilled yakitori, and baked croquettes all sitting in the same glass case. They've been there for potentially hours. And yet the fried items are still crispy, the steamed items are still moist, and nothing tastes like it's been sitting under a heat lamp slowly dying. The case isn't just heated, it's divided into microclimate zones. Each section has independent temperature control, but more importantly, independent humidity control. The fried chicken section runs at 85 degrees Celsius with humidity held below 20%. Low moisture keeps the coating crispy. The steamed bun section runs at 70 degrees with humidity above 60%. High moisture keeps the dough soft. These zones are separated by air curtains, invisible barriers of precisely directed airflow that prevent the humid air from the steamed section from migrating into the fried section. The airflow is strong enough to create a boundary but gentle enough that it doesn't cool the food. And the case adjusts itself throughout the day. Sensors monitor how often the door opens, how long it stays open, and how much temperature drops during access. The system compensates in real time, raising heat output slightly after someone grabs an item, then lowering it again once equilibrium is restored. You're not just looking at hot food. You're looking at a self-regulating microclimate management system disguised as a heated cabinet. Most convenience stores elsewhere just crank the heat and accept that everything will either dry out or get soggy. Japan engineered separate environments and made them coexist in one box. Number 7. The rice ball filling injection system that places the filling at the exact geometric center of the onigiri, ensuring identical taste experience in every bite. This sounds like a small thing until you've eaten enough onigiri to realize how rare it actually is. When you bite into an onigiri from a Japanese convenience store, the filling is always in the middle, not off to one side, not concentrated at the top or bottom, dead center, every single time. That consistency isn't an accident. It's the result of industrial filling machines calibrated to a degree most food manufacturing doesn't bother with. The rice is formed in a mold with a cavity in the center. The filling is injected using a nozzle that doesn't just squirt the filling in. It rotates during injection, distributing the filling evenly in all directions from the center point. The injection pressure is controlled so precisely that softer fillings like tuna mayo get lower pressure to prevent them from breaking through the rice, while firmer fillings like pickled plum get slightly higher pressure to ensure they settle correctly. After injection, a second layer of rice is added, and the whole thing is compressed in a mold that applies different pressure levels to different parts of the onigiri. The top gets less pressure to stay fluffy. The sides get more pressure to hold structure. The result is that every single onigiri has the filling in the exact same position, with the exact same distribution, so that every bite has the same ratio of rice to filling. You never get that annoying bite that's all rice or all filling. It's engineered consistency at a level that turns a convenience store rice ball into a more reliable eating experience than many handmade products. Japan took a simple food item and applied manufacturing precision that most people assume is reserved for electronics. Number 6. The bread moisture retention packaging that uses one-way breathable film to let excess steam escape while preventing external air from entering. Japanese convenience store sandwiches and pastries stay soft for days, not just edible, actually soft. The bread doesn't get that cardboard stiffness that hits most packaged bread products within 12 hours. The packaging film looks like normal plastic, but it's a laminated multi-layer material with microscopic pores that allow water vapor to move in only one direction. When the bread is packaged, it's still slightly warm from production. That warmth creates internal moisture. In a normal sealed bag, that moisture condenses on the inside of the plastic, then reabsorbs into the bread unevenly, creating soggy spots. In a fully breathable bag, the bread dries out. This film lets the initial excess moisture escape so condensation doesn't form, but then the pores close once internal and external humidity equalize, preventing any more moisture loss. The pore size is specific to bread type. Milk bread, which has higher sugar content and retains moisture differently than wheat bread, uses a film with slightly larger pores. Croissants, which need to stay flaky, use a different film altogether with pores that allow more airflow. And the film is treated with a food-safe coating that prevents oxygen penetration without blocking moisture vapor. The result is bread that stays at ideal moisture content for up to 72 hours without any preservatives beyond what's standard in bread production. You open a sandwich that's been on the shelf for 2 days and the bread is exactly as soft as it should be. Not stale, not soggy, just right. This is material engineering deployed to solve a problem most of the food industry just accepts as unsolvable. Number 5, the employee training system that teaches convenience store staff to assess customer intent and pre-prepare likely purchases during slow periods. This one isn't a physical technology. It's a human logistics system. Walk into a Japanese convenience store during the morning rush and the staff aren't just standing behind the register. They're preparing. If they see someone in business attire walk in, they've already moved toward the coffee station because data shows a 70% probability that person is buying coffee. If it's a student, they're positioned near the onigiri and ready to offer a bag. This isn't profiling. It's probability-based positioning taught through a training system that most retail chains don't bother with. New employees spend their first 2 weeks just observing customer patterns. What do people buy at different times? How do they move through the store? What items are commonly purchased together? Then they're taught positioning protocols. Morning shift workers learn to prep coffee lids and stirrers before customers ask. Evening shift workers learn to have chopsticks and napkins ready near the hot food case. The goal isn't to hover or pressure. It's to reduce transaction time by eliminating the small delays that add up. You don't have to ask for a bag. They've already assessed what you're buying and have the right size ready. You don't have to wait for them to grab chopsticks. They're already on the counter. The average transaction time at a Japanese convenience store is 40% faster than equivalent stores in other countries, not because the registers are faster but because the staff are trained to predict and prepare. It's retail choreography based on data observation, and it turns every employee into a logistics optimizer. Number 4, the quality control auditing system that sends anonymous inspectors to every store weekly, purchasing and laboratory testing food items for freshness, temperature, and microbial content. Here's where it gets serious. Japan's convenience store chains don't just trust their suppliers and logistics systems. They verify. Every single week, inspectors visit stores unannounced, buy random items, and send them to testing labs. The items are checked for temperature accuracy. If a product is supposed to be stored at 4 degrees, they measure if it actually is. They test for microbial content to ensure nothing is staying on shelves past safe limits. They evaluate texture, moisture content, and even taste against control standards. If a store fails, it doesn't just get a warning. The entire batch from that production facility gets pulled and the logistics chain gets audited. This isn't regulatory compliance. This is voluntary internal enforcement that exceeds what any government requires, and the results are published internally. Store managers see rankings, suppliers see performance data. Everyone in the chain knows they're being measured constantly. The result? You can buy an egg sandwich from a convenience store in rural Japan with the same confidence you'd have buying from the flagship store in Tokyo, because the same auditing system hits both locations with the same frequency and standards. Meanwhile, in most countries, convenience store food quality is a gamble that depends entirely on individual store management. Japan industrialized trust. Number 3. The single-serving soup packaging that uses a dual-chamber design to keep liquid and solid ingredients separate until heating, preventing over-softening of vegetables and proteins. You grab a container of miso soup or curry from the shelf. It's been sitting there unrefrigerated for potentially a day. You microwave it, and when you open it, the tofu cubes are still firm, the green onions still have texture, and the vegetables aren't disintegrated mush. The container isn't a single chamber, it's 2 chambers separated by a removable seal. The liquid broth or curry sauce is in the larger lower chamber. The solid ingredients are in a smaller upper chamber, vacuum-sealed and suspended above the liquid. When you're ready to eat, you peel the seal, which drops the solid ingredients into the liquid, then you microwave the whole thing. The solid ingredients only spend 3 minutes in the liquid before serving, which isn't enough time for them to break down. But here's the clever part. The upper chamber isn't just a separate container. It's designed with the exact volume needed so that when the solids drop into the liquid, the displacement brings the total volume right to the fill line of the container. No overflow, no waste. And the materials are chosen so that the upper chamber heats at the same rate as the lower chamber, meaning everything reaches serving temperature simultaneously. You don't end up with hot broth and cold tofu. It's thermally balanced. This is packaging that manages cooking timing through geometry and material science. Japan looked at the fundamental problem of reheating soup and solved it by rethinking what a container could do. Number 2. The the dessert temperature staging system used by suppliers to deliver frozen, chilled, and ambient temperature sweets in the same delivery truck without quality loss. Japanese convenience stores sell ice cream, fresh cream cakes, and room temperature pastries. All three categories have completely different storage requirements. Ice cream needs -18 degrees. Fresh cream cakes need 2 to 4 degrees. Pastries need 18 to 20 degrees. In most logistics systems, these would require 3 separate delivery trucks. Japan uses one truck with a tri-temp chamber system. The truck's cargo area is divided into 3 sections, each with independent refrigeration. But the sections aren't just separated by insulated walls. They're separated by active temperature barriers, which are essentially thin refrigerated panels that sit between zones and prevent thermal bleed. The system is so precise that you can have ice cream at -18 on one side of a barrier and fresh cream at +4 on the other side, with only a 6 centimeter gap between them. The truck's refrigeration system uses a variable flow coolant loop that adjusts how much cooling each zone gets based on real-time temperature sensors. If the ice cream section is opened during a delivery stop, the system detects the temperature spike and increases coolant flow to that zone without affecting the other two. The result is that a single truck can service a store's entire dessert inventory in one stop, maintaining perfect temperature for every category. This isn't just efficient, it's a reimagining of what refrigerated logistics can do. Most cold chain systems are single temperature. Japan built a vehicle that manages 3 simultaneous climates and keeps them stable through repeated door openings and varying outside conditions. Number 1. The seasonal menu rotation system that replaces 30% of convenience store food offerings every 6 weeks based on ingredient availability, regional festivals, and cultural food calendars. Walk into a Japanese convenience store in early April and you'll see Sakura-flavored everything. Sakura mochi, Sakura latte, Sakura anpan. Come back in July and it's all gone, replaced by summer items like chilled noodles, citrus drinks, and eel products for the stamina-boosting tradition around midsummer. This isn't just marketing, it's a complete supply chain reconfiguration that happens 8 times per year. Every 6 weeks, roughly a third of the food inventory rotates out. The replaced items aren't just swapped for similar products. They're replaced with items optimized for the specific season's ingredients, weather conditions, and cultural events. In autumn, chestnut and sweet potato products appear because those ingredients are at peak harvest. In winter, hot odin and nicumin increase in variety because customer data shows demand spikes when temperatures drop. But here's what makes this remarkable. The suppliers, manufacturers, and logistics networks all have to reconfigure simultaneously. A factory that was producing Sakura mochi in April is now producing something completely different by May. The delivery schedules change, the shelf space allocation changes, staff are retrained on new products, and this happens without interruption to daily operations. The system is designed for perpetual rotation. Contrast this with most convenience stores globally, where the same products sit on shelves year-round with maybe a few seasonal additions. Japan built an entire industry that treats seasons not as occasional opportunities, but as the core structural rhythm of product development. You're not just buying convenience store food. You're buying into a supply chain that reconfigures itself 8 times a year to align with how people actually want to eat as the world changes around them. So when Michelin inspectors started reviewing convenience store food and actually awarding recognition to some of these items, it wasn't a gimmick. It was an acknowledgement that Japan had built a food system that operated with precision, quality control, and innovation that most restaurants would struggle to match. If you want to see more things Japan engineered to a level the rest of the world hasn't caught up to yet, hit subscribe and check out the video on screen.